In this question, we've been given two column vectors and we've been asked to find and sketch the resultant vector. The resultant vector is what you get from combining two vectors together. In this case, we're going to combine A and B. So the resultant is A plus B. If we substitute these vectors in, we've got 10, -4 plus -4, 6. Focusing on the horizontal components, we're going to get +6, and the verticals, we're going to get 2. This is our resultant vector, 6, 2. We need to sketch this. We're going to sketch by starting with the thick dot, as usual, moving to the right by 6 and up by 2. So I have a component of 6 and a component of 2, and then my vector, my resultant vector, is A plus B. We could find this angle alpha. That may well be useful later. Part B of the question asks us to find the magnitude for the resultant vector. The magnitude is the length of the resultant vector, this diagonal length. We can find that by using Pythagoras. So 6 squared plus 2 squared gets us root 40. And root 40 as a decimal is approximately 6.325. That's the length, that's the magnitude of the resultant vector. In part C, we're asked to find the bearing of the resultant vector. Well, a bearing is an angle measurement, but a specific one. If we started from north and then we rotated clockwise until we got to the same direction as the vector. So that's this red angle that I've marked out. And I hope you can see that theta plus alpha would be 90, which means that theta is 90 minus alpha. I should be able to find alpha using the triangle that I already have. We know from right angle trigonometry that tan alpha equals the opposite over the adjacent. In this case, tan alpha equals 2 over 6. Alpha is inverse tan 2 over 6, 18.43. Theta is 90 minus 18.43, 71.57. And since it's bearing, we should have a leading zero, 071.57 degrees.